A working MCP server is not the same as a production-ready one. Once AI clients reach real tools, failures, misuse, and system pressure look different. In this section, we'll focus on the mindset and practices needed to detect problems, contain impact, recover safely, and keep improving. So far, we've built the MCP foundation, added security, designed reliable tools, and covered production operations. Now those pieces come together. Incident response is where architecture, access control, observability, deployment, and governance are tested under pressure, with real users and real systems at stake. An MCP server is more than an application endpoint. It acts as a control plane where users, models, prompts, tools, policies, data boundaries, and downstream systems interact. That changes how incidents look. A problem might be a normal outage, but it could also be an unsafe tool call, a prompt-driven policy bypass, tenant data exposure, or an action the model should not have triggered. The response mindset is safety plus reliability. Teams need logging, escalation paths, kill switches, and rehearsed decisions before uncertainty arrives. MCP incidents often fall into 4 overlapping failure domains. Security incidents involve access, unauthorized tool execution, token misuse, scope bypass, or tenant leakage. I-specific incidents come from model behavior, such as prompt injection, malicious tool instructions, or unsafe automated workflows. Reliability incidents appear when dependencies fail, timeouts cascade, retries amplify load, or rate limits break user flows. Operational incidents are the human and change management side: accidental deletion, bad deployments, misconfigured policies, or compatibility breaks. This classification helps responders choose the right first move: contain, neutralize, stabilize, or roll back. Imagine a support assistant calls export customer data, but the request is for the wrong tenant. The damage is not just the export. It shows that a tool path can cross a policy boundary. The causes are usually practical: missing authorization checks, overly broad scopes, stale tokens, or misconfigured policy. Start with the facts: who acted, for which tenant, with what scope, and what decision was logged. Then contain quickly by disabling the path, revoking credentials, and preserving evidence. Prompt injection often arrives as ordinary content: a ticket, email, document, or web page. The malicious instruction is blended into legitimate context, so the agent may treat it as something to follow. The failure can happen in several places. The model may obey the instruction, choose an unsafe tool, or misread tool results. Exposure becomes worse when a tool returns broad records without tenant filtering. The defense is layered: tight schemas, scoped permissions, consent for sensitive actions, and minimal outputs. If an incident occurs, trace exactly what data moved and through which tool. A common reliability pattern is retry amplification. An agent gets stuck in a loop, or retries pile up while a downstream service is slow. Suddenly, the MCP server is handling thousands of repeated tool calls, tokens spike, queues grow, and timeouts create even more retries. This is both an availability problem and a cost problem. Quotas, rate limits, circuit breakers, item potency keys, and back pressure give you safe ways to slow traffic, shed load, or isolate the noisy tenant. In practice, an MCP server is often only as healthy as the systems behind it. When a database, SaaS API queue, or search service slows down, the server may return partial data, timeout, or trigger a retry storm. The goal is not to hide the failure, it is to contain it. Use short timeouts, circuit breakers, bulkheads, and fallbacks, such as cached read-only responses, while clearly marking what is retryable, failed, or degraded. Destructive actions are where AI assistance needs firm guardrails. A mistaken interpretation can delete records, close tickets, change permissions, or send messages before anyone notices. Treat every mutation as a controlled workflow. Validate intent, check authorization, run a dry run, and require confirmation before execution. Afterwards, log the pre-state, post-state, actor, reason, request ID, and tool input. If something still goes wrong, recovery plans, restore procedures, notifications, and review help keep the damage contained. Effective incident response begins before anyone declares an incident. Detection signals come from logs, traces, metrics, audit events, policy denials, anomaly alerts, and user reports. In the first minutes, triage should turn noise into facts. What happened, who is affected, which MCP tools or integrations are involved, and whether the behavior is still occurring. Severity should be based on real impact: security exposure, tenant blast radius, data access or mutation, availability, cost, safety, and compliance deadlines. Then assign one accountable owner, so application, platform, security, and governance teams move together instead of debating ownership. Containment is not the same as shutting everything down. It means choosing the smallest control that stops the damage while keeping evidence intact. In an MCP incident, you can act at several layers: tool access, tokens, tenants, policy, and infrastructure. If a connector is behaving dangerously, quarantine that tool or version. If credentials are exposed, revoke tokens, rotate secrets, and narrow scopes. If behavior is uncertain, switch to read-only, add approvals, or lower quotas. For multi-tenant systems, isolate affected tenants first, before cleanup. The goal is controlled pressure reduction, not panic. Preserve logs, decisions, and timelines so investigation can continue. Recovery begins only after containment has stopped the unsafe condition. First, stabilize the service and verify that malicious access, bad automation, or faulty changes cannot continue. Then restore trustworthy state using backups, event logs, compensating transactions, or downstream reconciliation. Once the service is safe, communicate plainly. Who was affected, the time window, what data or actions were involved, and what remediation is underway. Finally, run a blameless review. The purpose is not blame. It is concrete improvement to detection, controls, runbooks, testing, and communication. A production readiness review is the systems check before launch. The goal is not to prove the team worked hard. It is to decide whether the service can operate safely under real conditions. Security asks whether the right people can do the right things and whether secrets and tenants are protected. Reliability asks what happens when dependencies slow down or fail. Observability asks whether the team will know what is happening quickly enough to respond. Governance asks who owns decisions, approvals, evidence, and retention. Deployment and operations ask whether rollout, rollback, support, and incident response are ready. Only then should the launch gate turn green. Readiness is a loop, not a launch checklist. A useful runbook tells responders what an alert means, how severe it is, who owns it, which dashboards to open, and how to contain or roll back safely. Drills turn that documentation into muscle memory. Practice unauthorized tool execution, possible data exposure, dependency outages, and destructive action recovery before they happen for real. Game days expose weak permissions, missing telemetry, unclear escalation, and coordination gaps. Then close the loop with reviews, audits, SLO evidence, and completed post-incident actions. Incident response and production readiness connect everything we've covered. Detect issues through observability, contain them with precise controls, recover while preserving evidence, and verify ownership, governance, security, and reliability before launch. Your next step is to apply these patterns in a production design review, capstone build, or real MCP rollout plan.